Welcome guys to another video where we are going to solve a simple inequality. The inequality includes the exponential e, and it is the e in the power of x plus 3 is greater than 3 multiplied with e in the power of x plus e in the power of 2 multiplied with x. So it seems a little bit hard, but it's not that hard, guys. You can solve it definitely because it's a typical problem that you will find many times in your mathematical career. So we start by bringing everything at the second part of the inequality. So we're gonna have, wait a minute, this is greater or equal. So we will write, let's call it inequality star, and we will write star like this. We bring everything to the second part. And we do whatever calculation we can do. So this will be 2 smaller than or equal to 0. An interesting thing that we can observe is that we can write the inequality like this with this term first, and we will have this over here minus 3, and as we can see, if we continue making some applies on this, it will be in the power of x and all of this in the power of 2, because we know that this over here, wait a minute, we know that whenever we have a real number and it is equal, let's say this over here bc, this is equal to a in the power of b, and all of this in the power of c. This is equal, we know this from our theory, so this is what we have done here. And we will have plus wait a minute, 2 multiplied with a in the power of x minus 3, smaller or equal to 0. And this over here, guys, it reminds us a second degree polynomial. So we can set, if we set a in the power of x equal to, let's say, a variable, let's say y, we will have y squared plus 2 multiplied with y minus 3, smaller or equal to 0. And we will continue solving this with the typical way. The delta will be b squared minus 4 multiplied with a and c. Here we can see that the a is equal to 1, b is equal to 2, and c is minus 3. And we continue doing the replacement. Will be 2 square minus 4 multiplied with a, that is 1, multiplied with minus 3, the c, and this is equal, wait a minute, let's write it as more analytical as we can, because it's always good to write analytical when you solve a exercise. The delta will be 4 minus minus 12, and this is equal to 4 plus 12 equal to 16. So delta will be equal to 16. It's greater than 0, so the two solutions of our polynomial of second degree will be y1.2 will be equal to minus b plus or minus of root square of 16 the delta to equal to 2. So, and this will be equal to, just do the replacement, minus 2 plus or minus root square of 16 is equal to 4 to 2, and we will have our two solutions. Y1 is equal to minus 2 minus 4 2. Number 2 will be equal to minus 6 to 2 minus 3, and y2 will be equal to 2 2 is equal to 1. So we have two solutions for our polynomial of second degree, and we know because delta is greater than 0, we will write the two roots over here. So we found that it is 0 to this, the value of this polynomial is 0 to this y1 and y2, and because delta is greater than 0, the polynomial will have the same sign of a, that a is 1, so it's greater than 0 outside of its two roots. So it will be positive here, and negative over here. The thing that we care about is to find where this polynomial is negative or equal to 0. So we write that cy will belong to minus 3.1, including in this space, including the roots over here. So the star inequality will exist if minus 3, if this over here exists. We have said that y is equal to e in the power of x, so we do the replacement again, the original replacement. So from this we can write, we see that a in the power of x must be greater than 0 of minus 3, this part of the double inequality, and then this part has always needs to exist 2, and a in the power of x must be smaller or equal to 1. We see this over here, the first inequality always exists because e is greater than 0, so there is no way to put the power of the e and the result will be negative or 0. So this over here exists always. So we write that a in the power of x is greater than 3 minus 3 exists for every x that belongs to the R. So we have this over here, we keep this, and then a in the power of x is smaller or equal to 1, and we know that, let's say, a in the power of 0 is equal to 1. So to make our lives much easier, we will write a in the power of x is smaller or equal to a in the power of 0, and then we know that a in the power of x is a function that is increasing function. The f function, let's say, equal to a is in x, a in the power of x is an increasing function and 1 to 1, so we can keep the smaller, so it will be x smaller or equal to 0. So we have the two solutions: x must belong to R and x must be negative or 0. So we will have this over here, all the values of R. The first part says that x is moving around here, everywhere here, but the second part tells us that x must be smaller or equal to 0. We have 0 here in the middle, so the values will be the 0 and whatever and left of 0, all the negative values. So we solved our inequality star, and the final solution is x must be smaller or equal to 0, or we can write x must belong to minus infinity point 0 closed bracelet here, because x can be 0 too. So that was the exercise for today, guys. I hope you enjoyed it, and see you guys in the next video. Please drop a like below because it will really help me.